Dear students, under the topic multiple integrals, we are learning problems under double integrals. Now, here we have the evaluation of double integrals where the limits of the integrals are not given. Previously, we solved double integral problems where the limits of the integrals were given. Now, here the double integral is given where we have to first find the limits of this integral and then integrate it. So the question here is evaluate double integral xy dx dy taken over the positive quadrant of the circle x square plus y square is equal to a square. So now here the region of integration is given using which we have to evaluate the limits of this integral. And after that, applying the limits, we have to integrate the given integral. Now, in order to find the limits of this integral, first of all, we have to sketch the region that is given. Now, if you see, the region given here is the positive quadrant of the circle whose radius is a. So, first of all, let us sketch this region. That is, we have to draw the circle with radius a, where a is a constant. So, with some constant distance, let us draw a circle. So first let us do that. So now here we have drawn the circle. This is x-axis and this is y-axis and this is the circle. And the radius that has been taken here is a. So if this distance is a, so it will be a comma 0 over here. Similarly, this distance is also a and the x coordinate is 0 with y coordinate as a. So this is 0 comma 0, the origin. So these are the radius. Now this is the circle that we have taken. So now here it is given as the positive quadrant of the circle. So what is the positive quadrant? It is the first quadrant that is positive. So this is first, second, third and fourth quadrant of the circle. Now the positive quadrant is the first quadrant, that is this region. So this will be our region under consideration. That is, we have to find a double integral in this region. So let me just shade that region and show you. So this is the region of integration. Now in order to find the limits of this region, we will be drawing vertical strip that will be moving along the x-axis. For example, you could see that we are going to draw vertical strip. So this is a vertical strip which is parallel to y-axis. So this vertical strip is parallel to y-axis and this vertical strip will be moving along the x-axis. So it will be moving like this. So you could see that the vertical strip moves like this so that we can find the limits for x. So what will be the limits for x? That is, this vertical strip will move from the x equal to 0 because it's from origin. So it is moving till where? Till this point. So it moves till x is equal to a. So therefore the limits for the variable x will be 0 to a. Since the strip moves from this point to this point like this, so it will be moving in. So using that movement we can find the limit for x. So the limit for x is from 0 to a. So let us write that first. So the limits for x is from x starts from 0 to it goes till a. So this is obtained how? By movement of the strip. So movement of the strip. Next we have to find the limit for y. Since the strip is vertical, that is it is parallel to y axis, we have to find the limits for y. In order to find the limits for y, it will be the length of the strip. So this is the length of the strip. Now how to evaluate this length? It starts from y is equal to 0 because we know that the equation of this line is y is equal to 0. So it starts from here and you could see that the other point touches the circle. Now what is the equation of the circle? Equation of the circle is x square plus y square is equal to a square. So from this we have to find the value of y. So having y square with this side, taking this x square to the other side, we get a square minus x square, which will give the value of y to be equal to square root of a square minus x square. So this is how we have to find the limits for y. Y is the length of the strip, and where it starts from this line. So the equation of this line is y is equal to 0, because wherever at all points of this, the value of y is 0 only. So it is y is equal to 0. It starts from here and it goes till this point, which touches the circle. So this point touches the circle, and what is that point? It is obtained from the equation of the circle. So what is the equation of the circle? X square plus y square is equal to a square, from which we obtain the value of y to be equal to square root of a square minus x square. And since this strip is moving, this point keeps on changing from here till here. So as the strip moves, because we know that the movement of the strip is like this, so as the strip moves, when it is here, we will have the value of y to be a. So as it keeps on moving, the points also change. So depending upon the value of x, each corresponding value of y will be taken. So in general, it can be taken as y is equal to square root of a square minus x square. So therefore, the limits for y is from y is equal to 0 to y is equal to square root of a square minus x square. So how this is obtained? This is obtained from the length of the strip. So length of the strip. Hope I have explained, I would have understood how to find the limits for x and limits for y. Since we have drawn the strip vertically, that is parallel to y axis, x moves from 0 to a, and the y gives is obtained from the length of the strip, which is from 0 to square root of a square minus x square. We can also draw the strip vertically also, in which case the limits will change. Y will vary from 0 to a, and x will vary from square root of a square minus y square. From 0 to a squared minus y squared. It is the other way of doing the problem. It can also be solved in that manner by drawing the strip parallel to x axis. Okay, so here we have chosen to draw the strip parallel to y axis, and so these are the limits. Now let us apply these limits and let us evaluate the given integral. So now we have to evaluate double integral, and the question is xy dx dy. So this is what we have been asked to evaluate. Now what are the limits? Limits are x equal to 0 to a and y equal to 0 to square root of a square minus x square. The limit which is independent of the variables has to be written outside. So which is independent? Now if you see, y is dependent on x over here. So this should be the inner integral limits. So limits of the inner integral. And here x is not dependent on any variable. So x is equal to 0 to a. So it should be the outer limit. So outer limit is for x. So x is equal to 0 to a. And the inner limit is y is equal to 0 to this one, that is square root of a square minus x square. So the inner limit. Now first we have to integrate with respect to y, after which we have to integrate with respect to x. So we can rewrite this integral as integral 0 to a integral 0 to square root of a square minus x square, and the function is xy. And what are we going to do? Since these limits are the inner limits, first we have to integrate with respect to y, and then we have to integrate with respect to x. So this is the idea of the problem. Now we shall start to integrate this. So that will be equal to, the outer integral remains as it is, as we are doing for the inner integral first. So now inner integral is integrated with respect to y. So x will be treated as constant, so it will come as it is. And what is the integration of y? Y is y squared divided by 2. And this is between the limits 0 to square root of a square minus x square, and we have dx over here, and that is equal to integral 0 to a. First we shall apply the upper limit. We integrated with respect to y, so at the place of y we have to substitute square root of a square minus x square. So it will be x multiplied with square root of a square minus x square, and this is y square, so the whole square, divided by 2, minus the lower limit, but lower limit if you apply completely it becomes 0, and this dx we have to write here. So next step is this integral will be equal to integral 0 to a. Now this square root goes off because it is we have the square over here. So x multiplied with a square minus x square divided by 2. The 2 can be taken out. So 1 by 2 dx. Now we shall multiply this x inside the bracket and we can write this as so I have multiplied this x inside. So 1 by 2 comes as it is. Integral 0 to a I have written here. And then when x is multiplied within, it will be like a squared x minus x multiplied with x squared is x cube dx. So now we shall integrate this. So we are going to integrate with respect to x. So this will be equal to 1 by 2. So when x is integrated, it becomes x squared by 2. So a squared x squared divided by 2 minus x cube when integrated, it gives us x power 4 divided by 4 between the limits 0 and a. And further applying the upper limit and the lower limit, it becomes 1 by 2. So when I apply the upper limit over here, a square we will have. So a squared multiplied with a square is a power 4 divided by 2 minus, and here also we have a to the power 4 divided by 4, and lower limit when we apply it becomes 0. So this will be equal to this 1 by 2 we will have as it is. We can take the LCM here, which is 4. So we have to multiply by 2, and when we multiply the 2 with a power 4, we get 2a to the power 4 minus, so 4 into 1, so a to the power 4. So what is 2a power 4 minus a power 4? It is a to the power 4. So 1 by 2 multiplied with a to the power 4 divided by 4. So on simplifying this further, we get a to the power 4 divided by 4 2 times is 8. So this is the solution. That is the region. We have evaluated the double integral over the given region. That is the positive quadrant of the circle. So this is a very significant problem in the examination point of view, and kindly follow the upcoming video lectures for more problems under the topic evaluation of double integral over a given region. Thank you.